Hello, my name is Asher Perez, and I'm going to be doing the video portion of our project. Okay, so the way I'm going to do this is I'm going to just go ahead and walk through the setup for geometry and the mesh, and then the setup stuff, and then I'm just going to go through what I already have for the actual sims that are being run, so that way I don't have to worry about sitting there and waiting for everything to run because it takes a minute. So yeah. Okay, so for the flat plate, we're going to go ahead and just drag out a fluent thing here. If you click on geometry, you'll see over here on the right hand side that we are in 3D analysis. We're going to change that to 2D. Okay, now we are going to use Design Modeler. You can use whatever CAD you want, but this is just what I used last year, so it works out easily that way. Okay. And it's going to take a sec to open. Okay. Now we are going to go ahead and center about the z-axis, because everything we're going to do is two-dimensional, so we don't need any z-axis. We're going to go to Sketch, and we are making a flat plate, so we're going to just take a rectangle, let's say like so, and then we're going to make a really big rectangle, like that. Okay, so now that we've got everything sort of out there, we're going to start dimensioning. So general dimensions here. And I'm just going to make all the dimensions and then edit them later because they're all edited in the same place, so it makes things easy. So, and then we're going to want one of these and one of these. Cool. Now, okay, let's look over to the left here, and we see H2 is actually going to be our length of the flat plate. Now that is given to us as 100 centimeters, so actually before I plug anything in, let me change my unit from meter to centimeter. Okay, and H2 is 900 centimeters, so let's take that down a bit. And then our V1 is going to be our height of the flat plate, so I think I went with 0.1 centimeters, so that's going to make it pretty thin, so that we can get a pretty decent approximation of what we're going to be looking at. Okay, now we got to define our area that we're going to be calculating the flow for. So you want it to be big so that you don't have any weird interferences with wall calculations, but you don't want it to be this big because this is a little ridiculous, so we're going to shrink it down. I believe I did 500 for, oops, that was not the right one. So H4 is our size. H5 is how far apart we are. So 500, and then V3 is our height here, so that's 500 as well. So we have a little box. Let's make this 250, and H5, was it? Yeah. Yeah, it's H5. We'll make that 250 as well. That way we're centered. Now I went ahead and actually moved mine 50 centimeters to the left. That way we're centered over the plate itself and not the axis. It doesn't super matter, but just figured it would be a good thing to do. Okay, so now that we have this all dimensioned out, you see our extremely thin flat plate here. Actually, I think I might have made this half a centimeter. Cool. Cool. Now we got to generate a surface from our sketch, and this is how we're going to do all of our calculations on this surface. So you're going to go to Concept, you're going to go to Surface from Sketches, you're going to select this, like so. Oh, okay. And then you're going to hit Apply. Now it's going to select that whole sketch, and you're just going to hit Generate. And now what you want to make sure you have is a hole right where your flat plate is, because basically we're filling out everything we want to do fluid calculations on. You can't do fluid calculations on a solid, so the flat plate is going to be a hole. Okay, so now we are done for geometry. So let's go ahead and save the whole project just to be safe. And then we can close out of this. Okay, now I'm going to go into the mesh. All these things are going to take a minute to open, so bear with me. Wow, this is a long time. Okay, it should be loading in our geometry now. Maybe if I close Excel, that'll help. Okay. Close all these two. Alright. Now, we have our geometry that we just made. We're centered about the z-axis automatically, so that's cool. So let's just go ahead and generate a mesh. Okay, so we see kind of a weird mesh, and that's okay, because I'm not a professional mesh person, so we'll kind of let this figure itself out. Okay, now we are going to add a, what's it called? Inflation, that's what it is. We're going to add inflation. So first you got to select the face that you're doing the mesh on. Then you got to come down to your flat plate here. Make sure you are in edge select. It's not necessary, but it makes it easier. And you want to do your boundary scoping method is geometry selection, so no selection. We're going to select that, and I have to zoom in a lot. That's 1, 2, 3. And then here is 4. And then apply. So now it's got that, and it's going to basically create a mesh that's sort of zoomed in on that. So we're going to do 5 layers just because. And there you go. And then let's go ahead and generate your mesh. And then click back on it. You can see it's generated that sort of zoom in. One thing I did forget to do is do our named selections. So we're going to take a sec. And so if you click these and then right click them, you create a named selection. This is important because ANSYS will sort of automatically select how it thinks the fluid should flow based on your name selection. So you really want to do this. It makes it a lot easier. So left side is going to be our inlet. Right side is going to be our outlet. Top, we'll call it semi. We'll call this semi as well. Okay, and then I'm going to get in here. Okay, so the only real stipulation with these is that you need to make sure you include the term wall. But other than that, let's do this line. And we're going to do create name 6 lines. This is going to be front wall, or leading wall, we'll call it. And then we're going to do upper wall. Lower wall. And then trailing wall. Okay. Now you can go ahead and click through your name selections here in your drop down menu. There you go. Inlet, outlet, sim, leading wall, upper wall, lower wall, and trailing wall. There you go. Cool. Now we'll go back to the mesh. Alright. So we're doing okay here, but we can get a little bit better. So we'll go to method. This is going to allow us to, we'll first go select the mesh you're doing, which is always going to be that. And then this is going to allow us to change how it's doing the mesh. So instead of using quadrilaterals, that's a hard word to say, we're going to use triangles. So yeah, there you go, triangles. Now we're going to do a sizing edit. So you click sizing, and then you're going to do your geometry selection again. Can I select this, please? Oh, edge select. I guess it is necessary. Okay, and then hit apply. So it's going to sort of give you this weird like 3D idea of what you're doing. I don't know why it does that. Okay, so element size we'll do 0.01. I did for my sim 0.001, but I'm just going to try to make this generate a little faster. And then generate. And if we hit mesh, you can see that's a much thinner, nicer looking mesh. And then the one thing we want to do is just increase our sizing around our edges. So we're going to do the same thing again. Select all of your edges. Apply element size. We'll do 0.1. This is what I did for real for the what's it called, for my sim. And okay, the mesh is done. What the heck? Oh, for some reason it did not save that I changed it. Okay, try now. Cool. Yeah, so that's decent. And you know, you can edit what you want here, but just know that the more nodes you put in, the more complicated you make it, you'll get a better sim, but your computer will run way worse. So yeah, cool. And then you're just going to hit save project always. Then you're going to update so that it knows that the mesh is done. And you can close out of here. Now you can see our setup is good. So we can open it up. You're going to hit 2D should already be picked. You don't want to be in 3D. You're going to do double precision and then start. Okay. Started on my second monitor here. So it's going to just kind of load everything in, and it'll show you your mesh. And then here you see those inlet and outlet labels were pretty cool. Worked out for us well. Okay, so let's go to model first off, and here we will change from viscous to, well, another viscous one, but it's just a different model. Should run a little faster, I think. Okay, and then we're going to enhance wall treatment, pressure gradient effects, because that's important for a boundary layer. I think that's all you got to do. Yeah, this should be fine. Okay, then we're going to go to materials, fluid, air. Now it has some generic air value in there, so we're just going to put in the Ozbay provided air value, which is, that's what he gave us. And then you're going to just hit change create, and then close. It doesn't close automatically, which is kind of not confidence inspiring, but we'll see in a minute how to check it to make sure it worked. So boundary conditions, velocity inlet. We are given that the free stream velocity is 2. So you're just going to put 2 in there. And apply. Cool. Now you have to close this one too. And yeah, that's the only real boundary condition you have to set for this one. So you're going to go to reference values, and this is just how to check you set everything up right. Reference at the inlet. Okay, so we see that we've got velocity is at 2 meters per second. Good. Viscosity is at 1.8 that we put in, and density is 1.2 that we put in. So everything's good. And let's go to report definitions next. So we want to do our what's it called? Force report. I don't know why I clicked surface report. And this is going to give us pretty much all the stuff we're looking for. We want to select the whole plate. And I'm going to name it force report. It's easier to get back to that way. You're going to hit OK. Don't hit compute because your computer will freak out. Close. OK. Now, one thing I like to do is change the residuals to 1e to the -6 and just go through all of these and do that. You don't have to do that. 0.01 will probably be fine. This just increases the quality of the solution. And I have a decent computer, so. OK. Now we should be good. We got to go initialize our solution. You want to do hybrid initialization, just hit initialize, problem solved. And then you're going to go to run calculation. I set my number of iterations to 1500. And then hit calculate. So I'm not going to do that because it takes forever. So that's where you would hit calculate. OK. And it's going to save while I quit. Okay, so now we'll go to where I did my flat plate here. We'll go to solution. Hope you guys are enjoying the video so far. Okay, it's just gonna load everything in. All right, cool. So this is my mesh for my sim. You can see it's a bit more intense, but it came out nice, I think. So, all right, here we were with 1500 iterations and running the calculation. Hit calculate. So what it's going to end up doing is it'll run this little plot while you're calculating it, and that will allow you to sort of keep track of the progress. Okay, so now what do we need? We need the velocity pressure contours. Okay, we need the velocity profile. We need the shear stress and skin coefficient and drag coefficient. Okay, so the last part, C and D, we can do in this area. So you see I already have them set up here, but you go to plots, XY plot. When you go up on this, it'll give you what you need. Say I was making my skin friction plot. I go skin friction plot. And then I'd go skin friction. So that's a wall flux skin friction coefficient. Then I want to make sure I'm selecting my upper wall. And yeah, so to check to make sure this is good, save plot will show me the plot. I didn't like it because I've already made it, so I will close this and pull up that plot. And so yeah, that's my plot. And then you can just hit write to file and then write. And it'll give you a little pop-up for writing out your file. It's going to go to a text file, so you got to just copy and paste it over to an Excel file. I don't think there's an option for, yeah, so not that big of a deal. Okay, and then you do the same process for wall shear, which will also be in the wall fluxes drop down. And this is what my wall shear chart looked like. Almost the same, except the values are different, but the curve should be the same because they're dependent. Okay, and then write that to a file. Now we need to calculate our CD because flat plate does not generate any lift at this angle of attack. So you're going to go to, where did I go? Report definitions, yeah. So where you did your force report before, you're going to open up a new report, and it's going to go, you're going to click force report, and then there's going to be a little drop down. Actually, I'll just do it real quick. So here, you go to new, force report, drag. So then you drag coefficient, you can name it. You want to do your whole plate is how I did it. You might want to do just the upper wall so that we get a more accurate flat plate simulation. Not sure. But yeah, I did the whole thing, so we'll stick with that for now. Oh my god, it hates me right now. Okay, and then you're going to just hit compute, and it will just sort of pop out a number down here for you. Cool. And that's your CD. Now, we're going to hit save. Okay, yep, save. We're going to get out of here. Then we're going to go to results. And this is where you're going to get your A and B stuff. Okay, pretend this is not here. It's not there. Okay, so this is what you see. Let me turn these lines off. So yeah, this is what you're going to see when you're coming in here. This is going to be this blank thing. You're like, what do I do? You go up here to contours. Name it contour 1. I named mine pressure contour and velocity contour, but I already have those names and I don't want it to yell at me, so I'm just going to leave it like that. So you can change your domain here. I did not do that. You want to change your location to your mesh, which is going to be called symmetry 1. You want to change your variable, not in this case, this is your pressure one. And then we're going to do 110 contours, and you're going to get something like this. I ended up changing my minimum and maximum here to get a little bit better picture, and that's how I ended up with this. Yeah, so you can kind of see the all important stuff. You get your stagnation point, you get a little void there, a little teeny little bit of a weak region, and then you can see, yeah, the rest of it's pretty consistent. Okay, so you're going to do the same thing. You're going to hit contour, then you're going to go 110. You're going to go to velocity. You want to also click your mesh again, and then you're going to hit apply. And yeah, I don't know if I ended up changing my range. No, it doesn't look like I did. So here you go. You can see your velocity's smacking in there, slowing down is nothing. And then you've got some high-speed stuff here because this boundary layer is starting to act like a, what's the word? Nozzle thing. God. Yeah, so this is all your boundary layer development. You can see everything slower down. Then here's your little wake region. Kind of looks like a rocket. It's kind of cool. All right. And I believe, oh, we need vectors. Okay, so now you're going to go to vectors, which is right to the left of that. You're going to say, okay, you're going to do symmetry 1. You're going to do variable velocity. And yeah, just pretty much use default settings for that. What is going on? This is so much cooler. Ah, that's why. Because on mine, I did equally spaced. This is doing it based on here. Wow, look at that. I'm going to put this on my report. That's really cool. Okay, let me take a snip of this real quick. I thought there was a way to pause this. Yeah, whatever. Snipping kill. Look at that. Real nice. Cool. Okay, so yeah, there you go. There's your vectors. You can see that we've got a little bit of deflection going on here. We've got some slowing down. You've got some stuff bouncing off of this plate. Ooh. And yeah, that's a pretty nice little situation. Okay, that should be it for part A, and it is. So once again, to summarize, vectors, pressure contour, and pressure contour and velocity contour. Cool. All right, now let's go to B. So this is the part where you got to make some lines. So up in top here, I believe. Where did I put that in there? Give me a second. Stop doing turbo machinery. No. Ah, there we go. Insert location. That's what you want. And you're going to hit a line. And what's going to come up is something like this. You're going to put in your points. I chose negative 0.5 because that's my plate that I made was to the left of the axis, so it was in the negative. So halfway along that plate was 0.5, or half a meter. And then I chose 0 and to 0.1 just because the boundary layer really doesn't develop much higher than that. I took 1,000 samples, and yeah, there you go, generates it. And you do pretty much the same thing for the end line. Why is it like that? I have no explanation for why that's off, because my rectangle was at 0 and this is at negative 0.001, and it was on the rectangle last time I looked at it, so that was not happening before. Anyways, here's your 2 lines, and then what you're gonna do to get your velocity profile is you can go up to here, you go chart, you go okay, then you're going to use your data series as from the location, and your location is going to pop up. Actually, I'll just open up my chart I already have set up so that it's easier. Okay, so I need velocity profiles with data series. See, you have 1 here, that's the half line. I chose location at the half line. Then you add another one using this little thing, and then you go here, add it at the half line. Cool. Now, x-axis, you want velocity. Y-axis, you want y. Then everything else should be okay. Yeah. And then you're going to hit apply, and you're going to get this. Now, what you can see going on is half line profile. You can check basically how second, because 2 meters per second is free stream velocity. If you're out of the boundary layer, you're back to free stream velocity. So you can see here we're kind of at a 0.032 for the half line, and for the end line, the boundary layer is much taller at about 0.055. Yeah, so that's as you would expect. They both look laminar because we are totally laminar throughout here, and the boundary layer is taller at the end than it is at the half line, but it is not linear because the half line is not exactly half of the height, because it goes like this. It's a square root graph. Cool. Is that all we need for this? Yeah, I think we're good. So yeah, that's how you do the first part. Awesome. I'm going to stop it.